Welcome to Chapter 10, the closing chapter of the course. Set the tone here. This isn't a new feature being bolted onto the site. It's a mindset shift for looking at everything students have already built. Over the last 9 chapters, students built a real website. Wireframes, semantic structure, CSS, responsive layout, forms, PHP, JavaScript, and finally a live database. That was the hard part. And it's worth pausing to acknowledge it before flipping the question. The question this chapter asks is different. Not, does it work? But, does it hold up if a stranger deliberately tries to break it? That's the capstone mindset shift the whole chapter is built around. Land the framing line clearly. Attackers don't need to outsmart the whole application. They just need to find the one gap nobody thought to close. Chapter 10 is about learning to think in terms of those gaps, and closing the ones in their own capstone site. This is the thesis slide. Give it room to breathe. If the chapter has one rule, it's this one. Never trust user input. Every form field, URL parameter, and cookie is a message from someone the developer doesn't control. Clarify what "don't trust it" actually means. Since students can misread it as paranoia, it doesn't mean assuming every visitor is malicious. It means assuming the data could be wrong, empty, unexpected, or occasionally hostile, and writing PHP so that none of those possibilities can cause harm. Preview the structure of the rest of the chapter here if it helps. Everything that follows is this one principle applied to 3 different attack surfaces: what gets displayed back to the browser, what gets sent to the database, and what gets accepted as valid in the first place. This slide exists to reassure students that none of this is brand new. They've been circling this principle since Chapter 6 without it having a name. Walk through the 3 callbacks explicitly. Chapter 6's form validation was an early, partial version of don't trust input. Chapter 7's htmlspecialchars toggle safely printed a value without students knowing the full security reasoning at the time. Chapter 9's PDO prepared statements kept user data separate from the SQL query string. Land the framing clearly. Today those 3 threads get a name, get explained properly, and get extended further than before. Cross-site scripting, XSS, happens when an attacker gets their own HTML or JavaScript to run inside your page, inside another visitor's browser, using your site as the delivery mechanism. Walk through the 3-step mechanism on screen. Your page echoes back text a user submitted. If that text contains a less than script greater than tag and gets printed as is, the browser can't tell it apart from code you wrote yourself, so it runs it. And because it's now running as part of your page, it has all the trust your site has. It can read cookies, rewrite content, or redirect visitors. Make this concrete for their own project. The Chapter 9 messages table stores whatever a visitor typed into the contact form. Chapter 9's Assignment 2 admin page displays that table. The moment stored data gets echoed back onto a P. Walk through the vulnerable code exactly as written. Echo $_post message with no protection at all. Under normal use, this looks completely harmless. Someone types, "great site," and that's what prints. Then show what happens when someone submits a less than script greater than tag instead of a normal message, one that redirects the page and exfiltrates document.cookie to an external site. Because the PHP echoed that text exactly as submitted, the script tag becomes a real, functioning part of the live page's HTML. Emphasize the part that makes this dangerous, rather than merely embarrassing. Every browser that loads the page afterward runs it, not just the original attackers. The payload is stored once, and executed against everyone who views the page after. This specific pattern is sometimes called stored. Remind students they already used this function once, back in Chapter 7 Assignment 2, to safely reflect a stored light/dark mode preference. Today they get the fuller explanation of why it actually works. htmlspecialchars doesn't remove or reject anything. It converts a small set of HTML special characters into harmless text equivalents. Walk through the conversion table if it's on screen. Less than becomes an LT, greater than becomes an GT, and so on. The browser then displays those as visible text, instead of interpreting them as markup or code. Make the callback to CH7 explicit and land the assignment connection. Today's Assignment 1 applies this exact technique to every field across the capstone site, not just the one place it was first used. SQL injection happens when user input gets pasted directly into a SQL query string, letting the attacker change what the query actually does, not just what's displayed, but what gets read, written, or deleted in the database. Walk through the 3-step mechanism. PHP builds a query by gluing text together with a $_post or $_get value inserted directly into the SQL string. An attacker submits SQL syntax instead of a normal value, a straight quote, keywords, a semicolon. The database has no way to tell attacker syntax apart from the intended query, so it just runs whatever string it receives. Draw the distinction from XSS clearly, since students will otherwise conflate the two. XSS is a display problem, happening at the moment content prints to a browser. SQL injection is a data problem. Walk through the vulnerable query built by string concatenation. $email is pulled straight from $_post and glued into the SQL string with no protection. As long as the submitted email is ordinary, this works exactly as intended. That's what makes it dangerous. It looks fine until it isn't. Explain the moment it breaks. A single quote in the submitted value closes the string the query's author intended to still be open. Everything typed after that quote becomes part of the SQL statement itself rather than a value being compared against a column. From there, an attacker who understands SQL syntax can attach clauses, comment out the rest of the query, or otherwise change what actually executes. Tie it back to slide 8's framing if useful. This is the same underlying mistake as XSS wearing diff. Remind students they already used this exact pattern in Chapter 9. Today's slide spells out the reasoning more fully rather than introducing new syntax. Explain the two distinct steps. Prepare. Sends PDO the query's structure, its shape, keywords, table and column names, with a named placeholder standing in for where a value will go. The database parses and locks in that structure before it ever sees the actual submitted value. Execute. Then sends the value separately, tagged as data rather than SQL to interpret. Land the key distinction. Because the structure was already finalized in Step 1, nothing sent in Step 2, no matter what characters it contains, can change what the query does. This is why prepared statements are a real fix, rather than a mitigation. They don't detect, or. Both kinds of validation are real and useful, but only one of them is actually security. That's the framing for this whole slide. Client-side validation, required attributes, type equals email. Any JavaScript checking a field before submit runs entirely in the visitor's own browser. It gives instant, friendly feedback, which is genuinely good UX. But because it runs in the browser, the visitor controls it, disabling JavaScript, editing HTML through DevTools, or sending a request straight to process.php, I'll skip it completely. It should never be the only line of defense. Server-side validation in PHP runs on the server, where the visitor can't bypass, disable, or edit it. This is the layer that actually decides whether data reaches the database or gets echoed to a page, checking required F. Walk through the before/after code, side by side. Before. $name is pulled straight from $_post and goes straight into the insert with no check at all. After, trim and the null coalescing operator are applied first, then an explicit check for an empty string. Explain both small details in the after version, since students will otherwise just copy them without understanding. Falls back to an empty string if the key doesn't exist at all, avoiding an undefined key warning. Trim strips accidental leading or trailing whitespace, so a field of only spaces doesn't slip past an empty string check. Close with the layering point, which is really the thesis of this whole section. Validation, escaping, and prepared statements are three separate layers solving three different problems. Validati. Beyond the two headline vulnerabilities, this slide covers smaller habits that meaningfully reduce how much damage a mistake can do. Treat this as a checklist students should recognize, even if they don't implement all of it on DreamHost. Turn off error display. Display_errors should be off in production, because a detailed PHP error handed to a random visitor or an attacker reveals file paths, table and column names, and query structure, all of which make further attacks easier to plan. Least privileged database users. The MySQL user PHP connects as should only have the permissions the app actually needs, not full admin rights. If that account is ever compromised, the damage is limited to what it was actually granted. Serve over HTTPS to encrypt data in transit. Keep secrets out of Pubble. Remind students where $get and $post came from. Chapter 7's built-in arrays for reading form and URL data. They're convenient specifically because PHP fills them in automatically from whatever request arrives, and that convenience is exactly the risk. PHP doesn't check that the data looks reasonable or is even present. Walk through the safer read pattern on screen. Trim. $post. Email. Single quote, closing parentheses dot. Point out this is the same pattern from the validation slide, now framed as a general default habit for reading any field, not just something reserved for the fields being explicitly validated. The comment on the last line is worth reading out loud, as basically the whole chapter in one sentence. Read defensively, validate what you read, escape it on display, and only ever use it in a query through. Use this as the visual summary of the full hardening pipeline. Escape, validate, prepare, running from untrusted input on one side to a lockdown application on the other. Good moment to pause for questions before moving into the closing section of the chapter. Shift tone here. This is the start of the closing arc of the entire course, not just the chapter. 10 chapters ago, a web page was just a text file. Now students understand the whole stack, from a single static tag to a database-backed, security-hardened site. Tell them we're about to walk that path together across the next 2 slides, before landing on the admin.php callback in the assignments. Walk through chapters 1 through 5 quickly as the foundations arc. How the web works with clients, servers, requests, and responses. Wireframes and semantic HTML for planning structure before styling. CSS structure and layout with the box model and selectors. content tags plus real visual identity, and responsive design with media queries and a hamburger nav. Keep this slide brisk. It's a victory lap, not new material. The point is letting students see the through line, not reteaching any of it. Chapters 6 through 9 brought the site to life. Tables and forms for structured data and user input, PHP for server-side logic and a real form handler, JavaScript for interactivity and motion, and SQL with PDO for a real database behind a capstone site. Land the transition explicitly. This arc leads directly into today's chapter. Everything from Chapter 6 onward is exactly what Chapter 10 is now locking down. This is the overview of today's deliverables before the detailed breakdown slides. 2 assignments, input hardening and database hardening, plus a 25-question quiz covering the whole chapter. Use this as a preview only. The next few slides go into the admin.php context and then the assignment specifics in detail, so keep this one brief. This is the payoff moment of the whole chapter. Give it weight. Chapter 9's Assignment 2 built admin.php to list every submitted message and deliberately left it with no protection at all. Anyone who knew or guessed the URL could open it and see every submission. Make clear that was intentional, not an oversight. It exists so this chapter has a real, concrete target instead of only abstract examples. Today's assignments bring output escaping, validated input, confirmed prepared statements, and now a basic password gate to that exact page. This is a good moment to have students actually pull up their own admin.php from Chapter 9 if time and setup allow. Seeing their own unprotected page makes the rest of the chapter concrete rather than theoretical. Assignment 1 covers input hardening across the entire capstone site, not just one page. 3 parts. Add htmlspecialchars. Output escaping anywhere user-submitted text gets echoed back. Add server-side validation to every form field required, trimmed, reasonably typed, and audit the existing Chapter 6 and Chapter 7 Philippine pesos files specifically for any raw echoed user input, fixing anything found. Emphasize the audit step, particularly. This isn't just applying the pattern to new code. It's going back through their own earlier work with a security lens now that they have one. Assignment 2 locks down the database layer and the admin.php page specifically. 3 parts. Audit the Chapter 9 PDO code to confirm prepared statements are used everywhere, no exceptions. Add proper error handling, attr_error mode plus try, catch, anywhere it's still missing, and add a simple password check to admin.php so it's no longer publicly viewable. Worth being upfront with students about scope here, echoing the narrative. A hard-coded password check is a real improvement over no protection and an appropriate stopping point for this course, but it's a classroom-level simplification. A production system would hash the password rather than store it in plain text, and would likely use a fuller authentication system. Knowing where the simplification is, and why a real system goes further, bring the whole semester into one frame. Chapters 1 through 5 gave the site a real, responsive front end. Chapters 6 through 9 made it dynamic and database-backed. Chapter 10 makes sure none of it can be casually broken. This is a good slide to let sit for a moment before moving to the closing slide. It's the structural summary of everything the course covered. Close the course here. From a blank page to a secure, database-backed website, built one chapter at a time. Let that land as the final note rather than rushing into logistics. Good spot for final questions about the assignments or the quiz before ending class, since this is the last content slide of the semester.